Now let's look at the question number 13 in the final exam for Teach Yourself Electricity and Electronics 5th edition, found on page 663. The same two inductors as we had in the previous question. However, instead of connecting them in series, this time they're in parallel. Again, there is no mutual inductance between them, which really simplifies things a lot in a case like this. The inductances in parallel combine in the same way as resistances in parallel do. Now this is a rather difficult question because we have these values that are so large. Let's use a little trick. We can say instead of 2,000 nanohenries that this is 2 microhenries and this is 4 microhenries. Now in order to determine the net inductance, we have to find the reciprocals of these values, add them, and then take the reciprocal of that. Well, the reciprocal of this is 1/2. The reciprocal of this is 1/4. Now let's add them, 1/2 plus 1/4, and we get 3/4. That's the reciprocal of this plus the reciprocal of that. These are not microhenries here that we're talking about, though they're reciprocal microhenries. They're meaningless units as far as engineers would be concerned. But the quantity, the value, 3/4. Now we take the reciprocal of 3/4 and we get 4/3. That is, once again, microhenries. So we have 4/3 of a microhenry, and that works out to be 1.333 microhenries. If you can do that in your head, probably. Now, that's not any of the choices that were given. However, we are given a choice in nanohenries, and of course to get nanohenries here we just multiply back by 1,000 to get 1,333 nanohenries. And that is choice B, as in bravo. A little messy, but not too bad. It's just arithmetic.